All right, so we're picking up where we left off. That's why I said example A. It says use the factor theorem to determine if the given polynomials are factors of the function that you see. All right, so we want to determine if x minus 3 is a factor of this polynomial. So like I say, you can do synthetic division or you can use your calculator. How about we take a second and you guys make that conclusion. Determine if x minus 3 is a factor of this function f of x. So like we came to the conclusion that it's easier to put in your calculator. So go ahead and type this expression into your calculator. We'll go look at our table and then we'll decide if it is a factor or not. All right, let me know if you need help putting it in your calculator. This is something you want to do, especially like even if you're getting ready to take one of these tests coming up, the ACT or the pre-ACT or whatever, and you haven't used a graphing calculator before. Like I would be using it like my life depended on it today, just so I get used to it. Yep. The up arrow and then whatever number you type is like. And it must be a setting like because it should look like that, but it still should work. Somebody probably just changed the print. All right, so type in just what you see. Make sure it works. Then I'll go look at the table. Everybody okay? What are we saying? Yes, it's a factor. No, it's not a factor. It's not a factor? What number did we put in the box, or what number are you actually checking? Negative 3 or 3? 3. So when x is 3, what do you get? Because we changed the sign, right? Because it's x plus 3. If we were doing synthetic division, in the box you would have 3, right? So we check 3 here. So basically, f of 3 comes out to equal what? 0. Is this a factor? Yes. It actually is. What were y'all doing? Checking negative 3? Yeah. Oh, okay. Make sure you change the sign. All right, so everybody okay with how we reached that conclusion? Yes, this is going to be a factor.
I think that's the table.
The table? Did you already plot it? Put the number, I mean? Did you already put the...
Yeah.
Okay, you hit the second button, and then you hit graph. That'll take you to your table.
Oh, okay.
Yep, and then you scroll up or down to 3, and f of 3 came out to equal 0. So, yes, it's a factor. So now we can actually use it to help factor this. So let's do some synthetic division. First, I'm going to write my leading coefficients. 1, negative 1, negative 11, 11, 12. In the box, I put 3. Got my line. Now I'm ready to go. And we know that this should come out to be 0, right? Because this should equal what my remainder is. Bring down 1. What's my next number? Negative 3. Or 3, sorry, I don't know why I did negative. What's the result when I add? 2. 2 times 3. Negative 11 plus 6. Negative 5. What's the next number? Negative 15. I add them together. Negative 4. Then what's the last number here? Negative 12. 12 plus negative 12 comes out to equal 0. Sure enough, these are factors. So let's write it factored form. So since x minus 3 is a factor, I write it as a factor, and now this is my simpler function that I have left over. What degree do I have 1x to? The third, 1 degree less. Good job. So x cubed plus 2x squared minus 5x minus 4. And I was able to factor this out. So now if I found another factor, I could do synthetic again on the simpler function that I have. So let's see if this is a function, if this is a factor, x plus 2. So I would change the sign, and let's see what f of negative 2 comes out to equal. We can do this pretty quick because we've already got this typed in our function. I just need to go to my table, and I see when x is negative 2, what do we get? Negative 30. So is this going to be a factor? No, it's not. So just to summarize, so when you look back, it'll make sense if you need to have it. So since f of negative 2 equals negative 30, x plus 2 is not a factor. And then we might try another one, or we might find another one. So if I went here, just for kicks, if I was trying to solve this, and I wanted to find another one, I don't see one that's relatively close. So there's another way we would have to attack this. We won't do it today, but that's kind of how this kind of process kind of works. You guys got any questions?
Is that a sense or like a sense?
A 6?
No, a sin, or is it?
It's supposed to be sense. I don't know why I just stopped in the middle of the word. I have no idea. I'm still on fall break, guys. I'm just let you know. I'll probably mentally be on fall break until like Wednesday.
What did you even do in fall break? I think it's not that long.
Went to the beach with like our whole family. My wife has 4 sisters, and they all have like significant others and grandparents, and it was like 20 of us in the beach house, and it was madness.
Was it chaos all week?
Yeah, pretty much. So yeah, madness. All right, any questions? All right, so let's go to the next example. Down to the left. And we read it, it says factor f of x given that negative 5 is a 0. So this is already telling us, we don't have to do the work, tells us that negative 5 is a 0. So we know this to be true. So we can go ahead and do synthetic division using negative 5. So you guys go ahead and do that. Since it tells me that this is a 0, after we do synthetic division, the remainder should be 0. And then we'll keep going from there. So you guys take a second and divide this. Let's even write what we have once we factor out this x plus 5 is what it would be. And then we'll continue solving from there. So you guys do synthetic division using negative 5. Everybody good? Told us it was a 0. Sure enough, got a remainder 0, so we know it's a factor. And remember, I changed the sign when I put it back with x. So x plus 5 is a factor. We factor it out. This is what we have left. Remember, since we divided it by x plus 5, we start our answer 1 degree less. So our function started off cubed. Since we divided it once with x to the first power, we started off with x squared. So now let's keep going. Let's actually solve this. All right. So let's solve this. And how many terms do we have? Because we got this one sorted out. We don't have to worry about this. This is x equals -5. We already found this answer. But I got 3 terms now. I might try to factor this into the parentheses like so, since it's a trinomial. All right. And I'll show you, there's really 2 ways you can do this. I do want to show you this way. I don't know if we've done one in my class where the lead number isn't 1, so it's just a little bit different, especially like how I do it. But it's a little bit different to what we would normally do. But we always think about what goes in the first spot. So first times first, in order to get me to 3x squared, I would need what times what? Let's just start off with the x's. I would need what times what to get me back to x squared? X times x. Okay, so I got to get 3. What 2 numbers can I multiply to give me 3?
3 and 1.
So my only options are it's got to be 3 times 1, right? So I give one of these a 3, the other one gets a 1, so I'll just leave it like that. First times first, I get back to 3x squared. Everybody okay? Now normally at this point we find factors of which number? 8, the last number, right? Now the difference this time is when we do outer times outer, it's not going to be x times this number, it's going to be 3x times this number. So that's just going to change how things work a little bit. What makes the most sense for me is I take this number and multiply it by the last number, which comes out to equal what? 24. Yep, -24. But like I said, don't get caught up on plus or minus. We'll deal with that when we put our numbers back. But you're right, -24. So now, when I get ready to find these factors, I'm going to divide one of them by 3. Because then, to get the number I want, 3 times whatever this number is, it's going to work out. So let's list the factors of 24. 2 times 12, maybe 3 times, 4 times 6, maybe 1 and 24. Let's see if any of these will work. I'm looking for the combination that gives me what number?
10.
Middle number 10.
4 and 6.
4 and 6, if you add them, okay. It could be 10 and 12 somehow too. Now if I think last times last, in order to get a negative number when I multiply, the signs have to be opposite, right? Like a positive times a negative or vice versa. So will 4 and 6 work if, for instance, it's -4 and +6? That'll give me like 2 somehow. Maybe I'm looking at this one now, because they're 10 away. Does that make sense?
So you can make 2 negative.
Yep, I could do -2, +12, gives me 10. Does that make sense? Now, if I just did maybe 2 and 12, my numbers are too big. Last times last gets me 24. 3 times 12, 36, 2. That's too big. So what I got to do is, I got to divide one of these numbers by 3. Which one is divisible by 3? And I'm going to break this one down. So I need that 3 times 4. And then my other number is 2. So now last times last 12, inner 2 gives me 10. 2 times 4 is 8. See how that works? So what I did was first times last. And just remember, you're going to have to divide this number by whatever is lead here. So I go over here and I just divide it by whatever my lead number is. All right, everybody okay? And we said which one needs to be positive?
The positive coordinates for
The bigger one. But this is what I got. Now I got a factor. I set each factor equal to, and I solve it. Let me go write this down. And then in the other space, I'll show you maybe another thing you can do. It might be a little easier. So we said 3x and x. We had 4. And we had minus 2. And I set each factor equal to 0. So x plus 5 equals 0. X equals negative 5. Three x minus 2 equals 0. Add 2 first. Then divide by what? 3. And I get 2 over 3. And then the last one, x plus 4 equals 0. X equals what? Negative 4. So we just solved that and we found our 3 zeros. Everybody okay with that? Now as you do this, I'll show you what you see if you put it in your calculator. So I'll put this in my calculator real quick, and you don't have to do this. You can if you want to practice, but I'll put it in hopefully pretty quick. And I'll graph it, make sure it works, everything's okay. And then I'll go to the table. So we knew that what number was a 0 to start off with? What number was given as a 0? Negative 5. So that's what you see right here. Just from looking, what other number is a 0? Negative 4. So what you can do is you can come back to this and do synthetic division just on this part. I want to show you that because some of you will want to do that. So now that I looked at my calculator, I saw that negative 4 is a 0. I know we know it now, but we didn't know this before. Looking at my calculator, I could have did negative 4 in the box, and I'm just focusing on the smaller piece. So I got 3, 10, negative 8. Bring down to 3. Next number is negative 12. What's this result? 10 plus negative 12, what's that? 10 minus 12, negative 2, thank you. 4 times, negative 4 times negative 2. Sure enough, I got a remainder of 0 because it was a factor. So at this point, I would have x plus 5. I've just found x plus 4. What do I have left over? 3x minus 2. That's the same thing as before using synthetic division. So you could have did this either way. Could have factored. Or if you put it in your calculator and you found another 0, you just do synthetic division again. Then once you simplify it, you just keep doing it until you get to that. And it's like, now at this point, oh, I can solve that. Set it equal to 0, like we did here. Then you solve it.
Find negative 4.
Use calculator. So, I typed the equation in my calculator, Silas. I looked at the table. Negative 5, that's one I knew. Then I saw another one. You might even scroll up and down and look for another 0, but our other answer was what? 2 over 3? Why do you think we don't see that one here? Because it's a fraction, and just from my settings, I can't see the fractions. And it's actually like a repeating decimal, so your calculator wouldn't be able to compute that and give you like a whole number. So yeah, we can see these whole real zeros here. Right? So either way will work. And we solved it. You guys got any questions?
So you found the negative 4 from your
Yes. Yep. Did you see what I?
Yeah.
Yeah, right there. So then I said, oh, let me do synthetic division on -4 because I'll get a remainder of 0. Or if you see this and you want to just factor it like this, do that. That's perfectly fine. All right, let's turn on the back. Got one more example of this. All right, so is -4 0? Or do I need to check it? It's a 0. It's a given that it is a 0. So maybe I don't trust my text in this. You can put it in and check, but it tells you that it is a 0. So you can go ahead and do synthetic division on that. So you guys go ahead and do synthetic division again on that one. And I don't know why I did this. Does that drive anybody else crazy?
Yeah.
Like it should? I guess, I don't know, the settings when I printed it, or I don't know, maybe I put it in backwards. But I do apologize. So we know -4 is a 0. Let's go ahead and divide it. Simplify our function. Just to be clear, what that's telling me is that f of -4 equals 0. So it's a factor. -2 is 1 too? Okay. So do synthetic division on one of them, and then do it again. And then what you should get it solved, because it's only to the 3rd power. So next number, -8, 1, 4, -10, 40. Sure enough, we got 0. So what I got is x plus 4, 2x squared minus x minus 10. Okay, so we should have got 0. That's what we got. We know it's a 0. So then I can write it factored. Then at this point, since it's a trinomial, you can try to factor it like we did before. Or if you put it in your calculator, you could maybe see if there's another 0. And I think Silas put it in his calculator and he found another 0. So let me show you that. I'll go ahead and, you can put either one. You can put the simplified one, or you can put the entire thing. I'll put the simplified one though. So we got x squared plus 7x. Sorry, I'm mixing the two of them. Minus x, right? And then minus 10. All right, looks okay. If you want the simplest method, just look. If you see a whole number here, that's a 0. I see right here, maybe on yours, -2. Or you go to the table and you look for any zeros. Do I have another one? What number? -2. So right here, when x is -2, I get out 0. That's going to be another 0. So I can do synthetic division again. As these get bigger, I'll show you how to just kind of keep this going, but I'll rewrite it. We're saying -2 is also a 0. So I'm going to do synthetic division on what I have left over. So I'm basically taking this, and I'm going to do synthetic division just on this. Two times -2, what's that? When I add, I get, okay, -5 times -2 is 10. When I add them, I get 0. So I just factored it another time. So at this point, what I have is x plus 4. We just found x what to? -2. But when I write it, is it +2 or -2? Yep, I got to change the sign when I put it back with the x. And then what do we have left over? 2x to what power?
The first.
The first, because we're going here. We started with 2, we divided it once more, 2x minus 5. Do we have it factored? We do. And then just to be clear, if you wanted to do the other way, first times first, x and x. To get 2, I would need to do 2 times 1, right? Right, okay? That's that. Then I would do 2 times 10, which is 20. And I would need a combination that's 1 away, because the signs are different. So 4 times 5, that's 1 away. The 4 I would need to divide by 2. So I would do 2x times 2. That's the 4. And then 5 is my other one. That's what we see right here. I just changed the order, just flip them. Okay, the bigger number needs to be negative. The smaller number, 4, needs to be positive. Either way, you get this same result. Everybody okay? So if you like doing this, do that. If you'd rather do synthetic division, do synthetic division. The only time you won't be able to do synthetic division technically is if you have like 2 numbers that are fractions, 2 answers. But if you got a whole number, do synthetic division. All right, so now I set each factor equal to what? 0, and I solve x plus 4 equals 0. X equals what?
Negative 4.
It's one answer. X plus 2 equals 0. X equals? Negative 2. Last one. 2x minus 5 equals 0. 2.5, yep. I add 5. Then I divide by 2. And this is one you won't see in the calculator because it's not a whole number. So we got 3 answers. Let's see how long our fall break was. What is the multiplicity of each one of these? How many times did we get this as an answer? How many times? How many times? 1 is odd, right? If the multiplicity is odd, what is it going to do? Cross or just touch and turn? Cross. Odd crosses, even touches and turns. Coming back a little bit? Let's go back even further. What's the degree? What's the highest degree term with the variable? 3. Is 3 even or odd? So since the degree is odd, I know the ends are going to be the same or opposite? Think about x squared. X squared is a parabola, right? If it's even, it's the same. So since it's odd, it's going to be opposite. Is it uphill or downhill? I think it's going to rise. This is your right? Because it's positive 2, it's going to kind of be uphill. So uphill is like this, right? So you just graphed it. You know this end is going to be like that. You know this end is going to be like that. And then you know these zeros is going to cross, so 1, 2, 3. Something like that. All right. Questions? I think I turned too many times. All right, so last one. It says, using the factor theorem to build a polynomial, write a polynomial f of x of degree 3 that has the zeros, 1/2, root 6, negative root 6. What is this asking me to make? Polynomial. Like this. So we basically are starting with the zeros, which is this in the boxes, and we want to kind of go backwards and make it into a polynomial that we know will have these three answers. So we're going backwards in a way. The simple fact that it tells me the degree is 3, that lets me know I should be looking for 3, like I should start off with 3 zeros. Now this is pretty black and white, but what if it said 3rd degree and you only saw 2 answers? I probably got one of these answers how many times? More than once, twice, because I need 3 total answers. We got 3 answers, 3rd degree. That lets me know everything has a multiplicity of 1. If it was like something had a multiplicity of 2, it would tell you that. You got 1 over 2 times. Then you say, oh, okay, I need to double that. So let's see, let's go backwards. So we're starting off knowing that our zeros are x equals 1/2, x equals root 6, x equals negative root 6. And we're going to build a function. We want these as our answers, so that's what we start off with. So now the next step is I need to make it look factor, meaning I need to move these numbers over so that it equals 0, and then I can factor together. So over here I've got x minus 1/2. That's a factor. What's the next factor? I need to move this over, right? So x minus root 6. It's my second factor. What's my last one?
X plus root 6.
Good job, x plus root 6. And we solved it, this is what we have. Or better yet, we should probably just say f of x. Okay, and remember, I want it to look like a polynomial to the 3rd degree, like this. What do you think we gotta do now? Maybe I start off with these 2 and I multiply or FOIL. Let's do these 2 first. I think it's going to get rid of our roots. So, not touching this one just yet, but it's still there. And now I'll FOIL this one. So, F is for first times first. What's first times first?
X squared.
O, outer times outer, x times root 6. Positive x times root 6. Inner times inner, negative root 6 times x. What's happening to these 2? Yep. And then last times last, negative root 6 times positive root 6. Well, what's root 6 times root 6? 6. Good job. So since they both have the same radical, you multiply what's inside of them. That would give you square root of 36, which is 6. That's how we get 6. The radicals basically cancel each other because you kind of get like root 6 squared, and these cancel each other out, and you're left with just 6. Okay, so is it plus or minus 6? Negative times positive, minus 6. All right, so let me write what we got a little cleaner, and we're almost done. Those middle terms canceled, and we got this. What do you think we got to do now? Multiply, right? Same thing as before. So we FOIL again. First times first. Good job. Outer times outer. X times negative 6. Good job. Inner times inner. Negative 1/2 times x squared. And then last times last. Negative 1/2 times negative 6. 3, yep. Plus 3. Right, then we just want to write it in order. We need the second term, the x squared, to come second, so just a little formality. This is my polynomial to the 3rd degree. All right, questions on that one? All right, so we got a few practice problems on Alex. I think it's only like, maybe like, no more than 10. I want to say it's like 8. It might be like 10, where we're kind of doing that first part. And if you don't like how we were able to go and look at the table in the graphing calculator to get our answers, some of you, especially if you're at home, you might not have a graphing calculator. You might just have to put it in piece by piece. I would suggest you just do it orders of operation and write it down as you go. You'll probably miss some questions, and you'll maybe call me over, and I'll kind of show you what I'm talking about if that applies to you. But